Welcome to the deep dive. Today we're taking a shortcut, you could say, into becoming well-informed about a really crucial part of building fast software. That's caching in Spring Boot. We've got a fantastic set of sources here that, well, they distill pretty much everything a beginner needs to know. We're talking annotations that act like simple instructions right through to properties that let you really fine-tune how your application stores data. You can think of caching as maybe keeping a quick reference notebook right beside your app for info it uses often. So our mission for this deep dive is clear. Help you understand how Spring Boot makes this easy so your own apps can get faster and more efficient.
Yeah, and what's really fascinating here, I think, is how Spring Boot takes what can be a pretty complex concept, caching, and just simplifies it. It offers this clear abstraction layer. It lets developers really focus on the application logic, not the intricate caching mechanics underneath.
Okay, so let's unpack this a bit. What exactly is caching in the context of Spring Boot? We mentioned the notebook analogy.
Right. It's essentially about storing frequently accessed data think user profiles, product details, things like that, storing them in memory, or somewhere faster than the original source. The goal is to avoid fetching it repeatedly from slower places like databases or maybe external web services.
And the result is faster apps.
Faster apps, definitely. And also less strain on those backend systems, especially databases.
And Spring Boot helps how? You mentioned the abstraction.
Exactly. Spring Boot provides this common interface, this abstraction, that can work with various actual caching tools. Popular ones like EhCache, Redis, or memcached. The annotations are basically the simple tags you add to your code to tell Spring Boot what to cache and when.
So this really translates into making our apps feel snappier for the user, right?
Absolutely. But, this raises a good question. How does Spring Boot actually enable all this magic behind the scenes? What's the first step?
Yeah, the switch. Is there like an on-off button?
Pretty much. That's the @enable caching annotation. Think of it as the master switch for caching in your entire application.
So you need that one first, otherwise nothing else works.
Correct. Without @enable caching, none of the other caching annotations we'll talk about will do anything. It's the absolute starting point.
And where does that typically go?
Usually you add it right on to the main class of your Spring Boot application, the one with the @Spring Boot application annotation.
Okay, got it. So switch is on. Now let's say I have a method that fetches user details. I want to cache that result. Which annotation do I reach for?
That would be @cacheable. This is probably the most common one you'll use. What it does is before executing the method, it checks the cache. Do I already have a result for this specific method call with these exact arguments?
Yeah.
If yes, bingo. It returns the cache result directly, and the method itself doesn't even run.
Oh, nice. So it skips the database call entirely if the data is cached.
Exactly. If the data isn't in the cache, then the method executes, its result is stored in the cache, and then it's returned to the caller.
So perfect for speeding up things like, say, retrieving a product's price, if lots of users are looking at the same product.
Precisely. It avoids those repeated database hits or complex calculations for the same input. Hugely beneficial for performance.
And you can get specific, right? Like naming the cache.
Yes, you typically specify a cache name, like a category, maybe users or products. You can also add conditions like only cache results if the user ID is greater than 100 or something like that. Gives you fine-grained control.
Okay. @cacheable saves the result and skips the method if possible.
Uh-huh.
But what if I have a method that updates user details? I always want that method to run, and I want the need details in the cache.
Ah, good point. That's where @cacheput comes in. It's different from @cacheable. @cacheput ensures the method always executes, every single time. And crucially, it then takes the method's return value and updates the cache with it.
So it doesn't check the cache first. It just runs and updates.
Correct. It doesn't skip the method execution. Its purpose is to keep the cache synchronized with the latest data, especially after an update operation.
So when a user updates their profile, @cacheput makes sure the cache immediately reflects those changes.
Exactly. You use it when the data changes, and you need the cache to be, well, reliably up to date after the change. Like @cacheable, you can specify cache names and conditions too.
Makes sense. @cacheable for reads, @cacheput for writes updates. Now, what if data becomes invalid? Like a product is deleted or a user closes their account. We need to get rid of the cached entry, right?
Absolutely. You don't want to serve stale or incorrect data. That's the job of @cacheevict. Think of it as erasing an outdated note from your notebook. It removes data from the cache.
Can it remove just one specific item or?
Both. You can configure it to evict a single entry based on the method arguments, just like at Cacheable, or you can tell it to clear out all entries within a specific cache using the allEntriesTrue attribute.
So useful when, say, a product is deleted to make sure nobody gets the old details from the cache.
Precisely. Or if a user's permissions change significantly, you might evict their cached session details. It prevents serving old, irrelevant information. Again, you can specify cache names and conditions.
Okay, enable, read, update, remove. That covers most bases. But what if one action needs to do like multiple things to cache, maybe update one cache and clear another?
Yeah, that happens. For those more complex scenarios, Spring Boot provides the @caching annotation. It's essentially a grouping mechanism. It lets you combine multiple caching annotations at cacheable, at cacheput, at tashevict onto a single method.
Ah, okay. So you could have one method that, say, updates a user's primary data with @cacheput in the user's cache, and simultaneously uses @cachevict to clear related entries in a user summaries cache.
Exactly like that. It gives you that extra flexibility for intricate caching logic without making your code super complicated. You just define the different operations within the @caching annotation.
Right, so we've gone through the main players.
Mm-hmm.
At enable caching, at cacheable, at cacheput, at cachevict, and at caching. Stepping back a bit, why should developers really embrace these? What are the big wins here?
Well, if we connect this to the bigger picture, the benefits are pretty substantial. We've touched on some, but let's summarize. First, speed. Plain and simple. Caching frequently accessed data, database results, even computed values dramatically reduces response times. Users notice that.
And let's load on the back end, right?
Definitely. Fewer trips to the database means less resource consumption, lower operational costs potentially, and it allows your application to handle more concurrent users without slowing down or needing more powerful hardware.
It also sounds like it makes development easier, surprisingly.
It does, in a way. Because Spring Boot handles the underlying complexity, developers can add caching with these relatively simple annotations. You focus on what needs caching, not the low-level how. It lets beginners, especially, focus on features.
And we mentioned it works with different tools.
Yeah, that flexibility is key. You're not locked into one specific caching technology. You can start with something simple like EhCache, and if your application grows and needs a distributed cache, you can switch the configuration to use Redis or memcached without rewriting all your caching logic. The annotations largely stay the same.
Plus, the annotations themselves offer flexible control, like the conditions we talked about.
Exactly. You decide what gets cached under what circumstances, when it gets updated, and when it gets removed. It's quite powerful.
So just revisiting the specific annotations quickly in light of these benefits, @enable caching is the foundation for any performance boost.
Right. @Cacheable directly saves time and database load for common read requests, like getting those product descriptions.
@cacheput keeps the cache fresh for data that changes but is still accessed often, like those user profiles.
And @cachevict is crucial for data integrity, preventing the use of outdated info, like for deleted accounts.
And @caching gives you that advanced control for complex, multi-step cache interactions.
Precisely. They really work together as a toolkit.
Okay, so annotations handle the what and when. But we need to tell Spring Boot how to cache, right? Like which tool to use EhCache or Redis, and where is Redis running? This sounds like configuration.
Exactly. That's where Spring Boot properties come in. These are settings you typically put in your application.properties or application.eml file. They allow you to control the application's behavior without changing the code. For caching, they tell Spring Boot things like which caching provider or implementation to use and specific settings for that provider.
So probably the most basic one is choosing the provider itself.
Yes, that's spring.cache.type. This property explicitly tells Spring Boot which caching system to activate. You might set it to EhCache, Redis, Caffeine, Generic, JCache, Couchbase, Infinispan, or even none to disable caching.
And if you don't set it,
Spring Boot is pretty smart. It will try to detect a supported caching library on your class path and configure it automatically. But it's usually better to be explicit with spring.cache.type to avoid surprises.
makes sense. What about organizing different caches? We mentioned cache names in the annotations.
Right, and you can pre-declare these names using the spring.cache.cacheNames property. You provide a comma-separated list of cache names like users, products, orders. This can sometimes help with initialization, and it clearly documents the intended caches for your application. It helps keep things organized.
Okay, now let's say we've chosen Redis. Spring.cache.type Redis. Redis often needs configuration, like how long data should live in the cache. Is there a property for that?
Absolutely, and it's
Okay.
a really important one for Redis. Spring.cache.redis.time to live. This sets the default expiration time for entries put into the Redis cache, specified in milliseconds. For example, 300,600,000 would set a default TTL of 1 hour.
Why is that so important?
Well, it prevents your cache from filling up with potentially stale data indefinitely. It ensures that old data eventually gets removed, freeing up memory in Redis and forcing a refresh from the source if needed later. It's crucial for managing resources and data freshness. Note, this is specific to the Redis Cache Manager.
And since Redis usually runs as a separate server, how do we tell Spring Boot where to connect?
Good question. You need to provide the connection details. The main ones are spring.redis.host and spring.redis.port. Spring.redis.host specifies the hostname or IP address of your Redis server. It defaults to localhost. Spring.redis.port specifies the port number Redis is listening on. The default Redis port is 6379.
So if Redis is running on the same machine for development, you might just need to set the type, but for production, you'd point spring.redis.host to the actual server.
Exactly. You might also need properties for passwords or SSL depending on your Redis setup.
What about EhCache? If we choose spring.cache.type EhCache, does it have specific properties too?
It does. A key one is spring.cache.ehcache.config. This property lets you specify the location of an EhCache configuration file, typically hashcache.xml. EhCache uses this XML file for its detailed configuration, things like setting maximum memory sizes for caches, defining different eviction policies like least recently used, setting time to live per cache, or configuring disk persistence.
So instead of lots of individual spring.cache.ehcache.properties, you point it to a dedicated config file for fine-tuning.
Correct. It allows for much more detailed EhCache customization, keeping those specific settings separate from your main application.properties.
So these properties, they really seem to provide that bridge between the simple annotations in the code and the potentially complex configuration of the underlying cache system. It offers control without muddying the application logic itself.
Precisely. That's the beauty of it. If we look at the bigger picture again, these properties simplify the setup significantly. You can switch caching providers or change connection details just by editing a configuration file. They allow you to choose the right tool for the job, maybe simple EhCache for a monolith, powerful Redis for a distributed microservices architecture.
And you can control behavior like TTLs, keeping data fresh and managing resources.
Exactly. And ultimately, this configuration-driven approach helps make your application more scalable and adaptable as its needs change over time.
Right. So for someone just starting out with Spring Boot caching, maybe feeling a little overwhelmed by all the options, annotations, properties, providers, what are some practical first steps or tips?
Yeah, that's a great question. How can you start simple and build up? My first piece of advice, start simple, really. If you're working on a standalone application, just use EhCache. Set spring.cache.typecache in your properties. It's built in, runs in your application's memory, requires zero external setup. You get immediate caching benefits with minimal fuss.
Good tip. And definitely use those cache names we talked about, right? Even if you start simple, using at cacheable my specific data and maybe spring.cache.cache names my specific data helps keep things organized from the start.
Absolutely. Name your caches clearly. It makes the code more readable and allows for easier configuration later if you need different settings per cache.
And if you do jump to Redis, don't forget that time to live.
Crucial. Set spring.cache.redis.time to live. Even a default value is better than nothing. It prevents stale data and keeps your Redis memory usage in check. Think about how volatile your data is when choosing a value.
Also, test locally first. If you're trying Redis, install it on your machine, set spring.redis.host, localhost, or 127.0.0.1, and make sure it works before deploying it somewhere more complex.
Solid advice. Get it working in a controlled environment first. And finally, don't be afraid to read the documentation. The official Spring Boot reference guide has excellent sections on caching, covering all these properties and annotations, plus more advanced topics if you need them later.
Okay, great tips. So we've really journeyed through the landscape of Spring Boot caching today. We've seen the annotations like @cacheable and @cacheevict that empower your code.
And the properties in your configuration files that let you precisely shape how that caching behaves.
It's really clear how these tools work together.
Yeah, and what's fascinating, I think, is realizing how these, well, seemingly small additions in annotation here, a property there, can fundamentally change an application. We're talking about performance, the user's experience, even the bottom line in terms of server costs, just by being smarter about data access.
Absolutely. By combining those annotations thoughtfully with smart property configurations. You really can make your Spring Boot app significantly faster, more efficient, and ready to scale. And importantly, you can achieve a lot of this without needing, a PhD in caching algorithms. Spring Boot handles a lot of the heavy lifting.
It truly does leverage powerful abstractions for powerful results.
So as you, our listeners, think about building or perhaps optimizing your applications, really consider how strategic caching, even started with the basics we discussed, could be that hidden superpower, that thing that makes our application stand out. What part of this deep dive, maybe one specific annotation or property, are you thinking about exploring further in your own projects now?